MCT4C, we're on our second unit. Polynomial functions in our first day is just an introduction. Shouldn't be very new. Want a few definitions first of all. A relation is any relationship that can be expressed in ordered pairs. A function is a specific relation where every element in the domain or our x values is mapped to, exactly one element in range. Or the y values. A different way of saying it is for every input, there is only one output or answer. Specifically, y equals x squared. We can picture that. It's our basic parabola. Smartboard not so friendly with the drawings. There we are. Table of values is -1. Let's just pick some nice x values. To find my y values, I would substitute those x values into the equation and I get only one answer. Y equals -1 squared is always 1. If I put the x value in 0, I will get 0, 1, 4, and 9. There is one specific y value for every x value. For the line, y equals 2x plus 3, I'll put the same values in. Substituting a -1 in for x, I would have -2 plus 3, which is 1. Put a 0 in, I'll get a 3, 5, 7, and 9. For every x value, there is exactly one answer for the y value. And it graphs very poorly. Slope of 2 up 3, like that. Another way of determining if something is a function, besides just looking for exactly one answer for every input, is a vertical line test. If any vertical line intersects the graph of the relation in one place only and always, it is a function. For the two functions above, any vertical line that I could draw on that parabola would only ever hit that parabola in one spot. It is a function. For the line, any vertical line would only ever touch that line in one place. It is also a function. I'm going to draw x squared plus y squared equals 16. You may or may not have seen this in grade 10, but it would be the graph of a circle with x-intercept 4 and -4. That's supposed to be a circle. Okay, a really lopsided circle. Y-intercept 4 and -4 is x squared plus y squared equals 16. But it is not a function Because it violates the vertical line test, I can draw some vertical lines on that relation, and it will hit in two places. That means that when x is equal to 2, I could have two possible answers on my relation. That is not a function if you can get two outputs for any input. When x is minus 3, which is what it looks like my other vertical line is, there are two possible answers to x equals minus 3. Therefore, it is not a function. The following mapping diagrams may help us with functions and non-functions. The first one has any Civic maps onto one thing, a Honda. So if you tell me Civic, I can only give you one answer, Honda. That is a function. Accord only maps onto one thing, Honda, and so on. Whereas beside it, on the non-example, if you give me the input Honda, I can give you two answers, Civic or Accord. That is not a function because for at least one of the inputs, there were two possible outputs. This one is a function. Each one of the x values on the left maps onto only one y value on the right. Whereas the one on the right side, 1, maps onto two different answers. It's hard to see. And the 4 also maps onto two different answers. That is not a function. Last two as well. The first one on the left is a function. Each maps onto only one thing. Whereas on the right-hand side, 21 gives us two possible answers. Of these four, which are functions and which are not? The one on the top left is a function. Each of those on the left maps onto one thing on the right. But on the right top, it is not a function because bread maps onto two things and drink maps onto two things. At the bottom left, that is also a function. Each one on the left maps onto one thing on the right. Notice that our arrows are going in a different direction for the bottom right slide. So these are our x values mapping onto our y values. And this is not a function because 4 maps onto two different answers. These are tables of values. It's another way to find a function is for any x value, you can only have one y value. This one is a function. Each different x value has one answer. But this one is not a function because 21 has two possible y values. A function, each x value maps onto one y value, and this one is also a function. It is in the wrong column. But each x value maps onto one y value. Even though that y value is the same in every case, that's okay. This one is a function. Each x value maps onto a y value, but this one is not because 0 has two possible answers, and 3 has two possible y values, not a function. Let's see of these 4, which ones are functions and which aren't. Top left is a function. Top right, each x value maps on to a y value. It is a function. But the bottom left is not a function because 1 has two possible answers. X equals minus 2.5 has 4 possible answers in the last one. It is not a function. Diagrams and graphs are probably the easiest to determine if it is a function or not. The first one is a line. And we know for every line, we're going to drop a vertical line anywhere, and it will only touch that in one place. It is a function because of the vertical line test. We already drew a circle, and we know that a circle is not a function because there are some vertical lines that will intersect at two different places. It is not a function. The third one, this wavy line, is a function because anywhere I drop a vertical line, it will only touch in one place. The fourth one is not a function because there are some places where a vertical line would touch in more than one place. Not a function. And there are two more hiding. There we go. Bottom left is a parabola, and each parabola can pass the vertical line test because it would only touch that parabola in one place anywhere. It is a function. Whereas when we tip it like this hyperbola, it would not be a function because a vertical line could touch in two places. Not a function. I'm going to give you a handout with some similar diagrams and get you to quick just check that you know a function and a non-function. Domain and range you have probably seen before in grade 11, but let's write a definition down. Your domain, or your allowable, you could use the word valid or appropriate, X values, or your input. There we are. The range is the same idea. It would be the allowable or the valid Y values, or the output. We usually write domain and range as a set, so it would be in curly brackets. Same with the range. We often write domain equals, and we would indicate what were allowable values for X. For instance, a domain could be X has to be greater than or equal to 3, but it's not just dots, it's solid continuous function. Sorry, that should be an X. Not good enough chocolate going tonight. X is a real number. So that's what it would look like when we could write a domain. A possible range could be my Y values have to be less than or equal to 2. And it is a continuous function. So we'll get used to how to write those, but I wanted you to see it before we moved on. X-intercept is where the function or the graph intersects the x-axis. And a few other definitions for us. Binomial actually means two names. We mean two terms. So a binomial could be something like 3x plus 6 or 4a minus 7 would be good examples of binomials. A trinomial is 3 terms. And we worked with trinomials last year when we did quadratics, binomials with lines. A trinomial has 3 terms such as 2x squared plus 6x minus 7. We're going to be working with polynomial functions. And a polynomial is many names or many terms. Polynomial function is a function in form f at x, function notation, equals an, don't panic, an xn plus an minus 1 xn minus 1 all the way to the end, a2 x squared plus a1x plus a 0. Where n is a whole number, and is the degree of the polynomial. So if you have a fourth degree polynomial, x to the fourth is your largest power. We will have coefficients from the first one all the way to the nth one. And they are real numbers. For example, let's do one because they're kind of ugly. For example, f at x equals 7x cubed minus 3x squared plus 4x minus 1. This particular polynomial function has degree 3. It also has the name of a cubic. It has the coefficients a0 all the way to a3. Those are just fancy little terms for a0 was the minus 1 at the end. The 4 is a1 because it goes with x to the 1. a2 is a minus 3 because it goes with x squared. And a3 is the 7 that goes with the x cubed. It's just the 8th term is a minus 1. 8 at the 0th term is minus 1. The first coefficient is 4, and so on. They're just fancy names for them. If you have a constant function, f at x equals 7, that has degree 0. There is an invisible x to the 0 beside that 7, 0 degree. So we're going to just practice looking and recognizing functions and a little bit with polynomial functions. I have a short handout that shows you functions and non-functions and textbook, page 82. So I'll just write that down. 2.4.2, 2.4.4 I'm going to give you, and then page 82. And it has a wonderful example on the top of that page, numbers 1 to 10. 11, 12AB,